Let's take a look at the method for factoring trinomials. And this time we're going to look at trinomials of the form ax squared plus bx plus c, where the coefficient in front of the squared term can really be any non-zero number. So I'm going to look at two different methods. One is called the FOIL method, which really involves kind of making some educated guesses and then checking. The way this works, it's kind of a nice way to kind of think about it, and if the problem's not too complicated, we can maybe figure it out this way. It's not my favorite method though, because it is based on guessing and checking, and so we have to kind of make good guesses. So the FOIL method, if this factors, then I know it's going to look like x plus or minus something and x plus or minus something, with maybe a number multiplied with the x. And so if you think about what FOIL has us do, it's going to have us multiply those two together, and then whatever's at the end here, we're going to multiply together those as well. And the x squared term comes from multiplying the two x's together. So I know the number in front of the x, those two numbers, they have to be factors of 3. They have to be factors of the a number. So in this case, a equals 3. The numbers at the end, these two numbers have to be factors of 8. So in this case, 3x squared plus 14x plus 8. 3 doesn't have very many factors. Really just the only factor pair would be 1 and 3, because 3 is prime. So one of these numbers has to have a 3. Has to be 3, and the other number would just be a 1. The other pair, at the end, we have some choices. This could be like a 1 and an 8, or it could be 2 and a 4. So we have a couple of different factor pairs that multiply to equal 8. So, we could test them out. I mean, we don't have too many choices to make. I do know, and you might remember this from our earlier discussion, because everything is kind of positive here. It turns out that the factors are going to have the same sign in order to multiply to equal positive 8. And then because it's a positive value in the middle, I know that they have to be positive. So that kind of tells me and helps me understand that a plus sign is going to work. Although, in sort of the complete world of guessing and checking, we could maybe consider a negative sign too. But I can tell that things have to be positive. So let's think, if I put an 8 here, and then a 1 over there, I would get 3x times 1 and 1 times 8, but that would add up to 11, 11x. And so we want 14. So 8 and 1 aren't going to work, right? Because if I put a 1 here and an 8 there, then I get 24x plus 1x, and that's just way too big. So let's think about 2 and 4. If I put a 2 here and a 4 there, I end up with 6 and 6x and 4x, and that's 10, so that doesn't work. And the only other option then is to put a 2 here and a 4 there, and let's see. So then, checking with FOIL, I get the outside terms would give me 12x, and the inside terms give me 2x, and 12x plus 2x equals 14x. So the guess that works, and we can double check this one more time, is going to be 3x plus 2, and then x plus 4. So to check that, and just one more time, with FOIL, the first terms gives me 3x squared. The outside terms gives me 12x. The inside terms gives us 2x. And the last terms, 2 times 4, gives us 8. So those middle terms, the outside and the inside terms, add up to what we need, 14x. And we have our answer. A more systematic approach for a problem like this is called the AC method. So it gets a little bit more into some details of algebra. And so for some simple problems, guessing and checking is maybe not a bad approach. But if you want to be sort of systematic and not have to make lots of guesses, the AC method is maybe a better strategy to apply. So let's take a look maybe quickly at this same process, and then I'll post a separate video with some examples, more examples of the AC method. So for this problem, if I wanted to apply the AC method, A, of course, refers to the coefficient of x squared, and C refers to the constant term. So A times C is 3 times 8. A times C equals 24. And so similar to just the simpler problems that we've looked at, 24, what I want to find is a factor pair of 24 that adds to equal 14. So I'd like to find a factor pair of A times C. I'd like to find a factor pair of 24 that adds to equal B, that adds to 14. And so since 24 is positive, I have a positive 3 and a positive 8, I know the two factors have to have the same sign, and since they have to add up to a positive 14, they have to both be positive. So now, I can be systematic about this. I can go through the list, always, starting with 1 times the number, and then 2 divides into 24, and 3 divides into 24, and 4 divides into 24, and then that's kind of it, because 5 doesn't work, so then 6 times 4 would be the next factor pair, but that takes us around, it just kind of reverses the order of everything. So looking at these 4 options, these are the only options that we have, and of course 2 and 12 add up to 14. So now here's where the algebra comes in. To use the AC method, what I would want to do next is 3x squared. I'd want to rewrite this middle term using those factors. I know that 2 and 12 add up to 14, so 14x is exactly the same as 12x plus 2x. And so what I'm going to do in this expression, I'm going to replace the 14 with 12x plus 2x. And then to finish the problem, I want to factor by grouping. So if I look at the first two terms, 3 and 12 have a common factor of 3, and then there's an x squared and an x, so I can factor out a 3x. And what's left behind is x plus 4. 2x and 8 have a common factor of 2, and what's left behind is x plus 4. So x plus 4 is a common factor. I can factor that to the front. And from this first group, there's a 3x left behind. The thing other than the x plus 4, the other factor is 3x. And then left behind from the second group, if I take away the x plus 4, there's a plus 2. And so we get the same factorization, of course. There's only one way to factor the trinomial. We end up with that same answer. I guess the order is slightly different, but it's the same factorization. And we didn't really have to do any guessing. We just had to kind of look through the list of factor pairs of A times C. I hope you enjoyed the video. Thanks for watching.